Hello friends, in this video we are going to discuss about the operation of PMOS transistor in the triode region. So we know that PMOS means P channel E only MOSFET, and triode regions means the linear region or the ohmic region. So the condition that should be achieved by the PMOS transistor to be in the triode region is that the drain to source voltage must be greater than the drain to source saturation voltage, or we can say that VDS should be greater than gate to source voltage minus VT. Now the ID equation that can be written in the triode region for the PMOS is ID equals to mu P COX W by L VGS minus VT into VDS minus VDS whole square divided by 2. So this is the equation that will define the drain current in the triode region for the PMOS. Now this equation can also be written by neglecting the value of VDS. So if we neglect this VDS square value, then it can be written as mu P into COX W by L into VGS minus VT into VDS. So this is the final equation of ID by neglecting the VDS square divided by 2. Now we can see that mu n COX is a constant where mu p is the mobility of the holes and COX is the capacitance due to the oxide layer. So we can term this constant by a single constant Kp, where Kp is equals to the process transconductance parameter of the PMOS in ampere per volt square. So the final equation of the ID by putting the value of Kp can be written as ID is equals to Kp into W by L into VGS minus VT into VDS. So let Kp dash is equals to Kp into W by L. If I put the value of Kp dash, the equation of ID will be Kp dash into VGS minus VT into VDS. So this equation is the final equation of the ID in the triode region. Now we can find the value of transconductance, drain to source resistance and the output conductance of the PMOS. Similarly, in that we have done for the NMOS in the triode region. So as we know that the drain to source resistance, that RDS or the channel resistance, is defined by VDS divided by ID. So from this equation we can find the value of VDS by ID, which will be equals to 1 by Kp dash VGS minus Vt. So it will give the value of drain to source resistance or channel resistance in ohm. Similarly, we can find the value of transconductance also. So the value of transconductance, that is Gm, can be written by del Id divided by del of Vgs, keeping Vds constant. So it can be written as, we know that Id value is given by Kp dash into Vgs minus Vt into Vds. So the value of Gm can be found from this equation by del Id by del of Vgs. So this equation can be written as del of Vgs into Kp dash into Vgs into Vds minus Kp dash into Vt into drain to source voltage. So if we do the partial differentiation, then we can find it as Kp dash into Vds minus Kp dash into Vt into Vds. So this will be the value of del Id by del Vgs, that is the Gm. Similarly, we can find the value of the Gd also, that is the output conductance. So Gd is written as, we know that is del Id by del Vds in mho, and we have the Id equation like this: Kp dash into Vgs minus Vt into Vds. So if we do the partial derivative of del Id with respect to the Vds, we can find it as Kp dash into Vgs minus Vt in mho. So these are the third parameter, that is the output conductance or the drain conductance, that can be calculated from the triode region. So this is all about the operation of the PMOS transistor in the triode region. Thank you.